Welcome to our APRA CPS 230 series of video blogs, helping organisations to understand how they can automate and streamline the technology risk management processes required to improve operational resilience. In this video, we'll discuss the need to conduct scenario testing in order to meet your organisation's impact tolerances required to deliver critical operations as defined within CPS 230 requirements 27C and 44. I'm Marc Woolward, the CTO at vArmour, and I have several decades' experience of managing technology risk within mission-critical environments. Once you have accurate information about your critical operations and their constituents, then you can begin to ask questions around specific risks and failure scenarios. The vArmour map makes this easy to conduct using a traditional tabletop approach, but it also enables the encoding of rules to detect when specific impact and risk tolerances are breached. For example, where recovery time objectives of dependent systems cease to be consistent. With Relationship Cloud, scenario analysis can begin to become continuous and automatic. So here we will go back to the application view for the critical business function mobile banking and begin to work through the dependencies and the scenarios we need to consider which might cause my critical business operation to fail to meet its impact tolerances. For this exercise, let's focus on the dependency between mobile banking and the upstream service risk calculators in order to understand the properties of that dependency and to assess a number of scenarios. So here we see the detail about the dependency between the mobile banking application and the risk calcs application, which is, as we can see here, is an upstream dependency. So mobile banking is dependent upon risk calcs. So the first thing we can see is there is a large number of systems involved in the communication path between the two different services. In fact, what we see here, if we take a quick look, is it looks like that there's a cluster of 6 systems active on the mobile banking side, communicating with a cluster of 6 systems on the risk calc side, and it looks like there's actually active full mesh of communications between them. So, you know, at a high level, it looks like there's a high degree of resilience and redundancy here. And the other thing that I'd say about this view is it also shows us that this behavior has been observed within the past 30 days. So this is an active, ongoing behavior of the application. But let's think about this a little bit more deeply. And let's think about things like recovery time objectives. So recovery time objectives are the measurement of the time that an application is expected to recover within. And typically, if you have an application and it has an upstream dependency, your RTOs need to be at least consistent, or the upstream app needs to be able to recover faster. So let's take a quick look at that. So I come across to the filter, and I select the RTO label, and I can see within this map there are RTOs of 2 and there are RTOs of 4. So let's explore this. If I hover over the RTO of 4, I can see that that is actually the recovery time objective for my application mobile banking, or for at least this function within it. And then if I hover over the 4, I can see that actually the risk calcs application itself has a recovery time objective that's longer than my application can tolerate. So this looks to me like we have a potential scenario within our test whereby if there was a failure within the risk calcs application itself, it would recover within 4 hours. That would not be long enough for me to meet my impact tolerances as described within the RTO for my service. So we have a potential issue here. There's another thing we could consider as well, which is geographical diversity and resilience. So it looks like we have a high degree of resilience in terms of systems providing this dependency. But let's take a little look about as to how they're distributed geographically. So if I go to the region within the filter bar, I can see that again this dependency is provided across an Azure data center in the central United States and my New York data center. So this could be okay, but let's take a look. If I hover over my New York DC, I see that all of the servers delivering the dependency from the RiskCalcs app to my mobile banking application are deployed within the same data center. So what I have here is a potential single point of failure or concentration risk that's being represented by my upstream dependency being deployed only within a single data center. It feels here like I have at least two areas of potential risk to my ability to recover. So within this scenario test that I've just run quickly through, I've uncovered two potential issues that I need to either go and triage and either risk accept or I need to remediate. So how do I do that? Well, that's easy too. I'll look for the owner within the filter bar, and Henna Daly is the owner for my application, mobile banking. TJ Summer is the application owner for the systems that I'm dependent upon. So it feels to me like it's time for a conversation with TJ Summer. So let's recap what just happened here. In a couple of minutes, I've assessed an upstream dependency within an upstream application using information that's been collected from the environment, guaranteeing its accuracy and timeliness. This is all within the last 30 days, and without involving anyone else from other teams. The days of periodic, manual and expensive scenario testing involving many individuals and teams are over here. Relationship Cloud enables critical operations owners to self-serve their scenario testing, and it also ensures the accuracy of the work conducted. But that's not all. The vArmour rules engine policies enable organizations to encode many of these tests so that they are continually evaluated. So this capability allows an organization to meet the requirements of CPS 230, requirements 27C and 44, and also to continue to do so on a continuous basis. Thanks for listening.